Welcome to this module, Generative AI in .NET with Ollama, RAG, DDD Architecture, and Clean Architecture. In this section, we are going to build a practical AI-powered backend application. The goal is not only to call an AI model from .NET, but to do it using a clean, professional architecture. We will use a .NET Web API, Ollama for local AI models, PostgreSQL to store data, pgvector for semantic search, and architectural principles from DDD and Clean Architecture. By the end of this module, you will understand how to integrate generative AI into a real backend solution. The final demo can be explained in 3 simple steps. First, the user asks a natural language question about the CV. Second, the API processes that question, searches for relevant fragments of the CV, and builds useful context for the AI model. Third, Ollama generates an answer based only on that context. This is very important. We don't want the models to answer from general knowledge. We want the model to answer using the CV information retrieved by our backend. This is the foundation of the RAG approach that we'll explain in the following chapters. This slide shows the main flow of the application. The user sends a question to the API. The .NET Web API receives that question and starts the backend process. Then, the system generates or uses a vector representation of the question. This allows us to search by meaning, not only by exact words. After that, we use RAG to retrieve relevant context from the CV. Finally, Ollama retrieves the context and the question and generates the answer. The key idea for junior developers is this: we are not doing magic with AI. We are building a backend flow with clear responsibilities. Each step has a purpose, and each part of the system will be placed in the correct architectural layer. In this solution, we will use several components. The first component is the .NET Web API. It will expose endpoints to upload the CV, process it, and ask questions. We will also use libraries such as Microsoft.extensions.ai and semantic kernel to work with AI concepts in a more structured way. The second component is Ollama. Ollama will allow us to run local chat and embedding models in a development environment. For production environments, we can consider alternatives such as VLLM. The third component is PostgreSQL. PostgreSQL will store documents, chunks, and conversation history. We will also use pgvector, which allows PostgreSQL to store vectors and perform semantic similarity searches. Docker Compose will help us start the local infrastructure in a reproducible way. And finally, Clean Architecture will help us avoid coupling the API directly to specific technologies. At the end of this module, the student will be able to test different types of questions against the CV. For example, what experience does Jordi have with .NET? Has he worked with DDD Architecture? Does he have experience delivering training? What cloud or DevOps technologies does he know? The expected result is useful and professional answer, based on the content of the CV. Another important behavior is that the chatbot should recognize when there isn't enough information. If the answer is not in the CV, the chatbot shouldn't invent it. It should clearly say that there isn't enough information in the provided context. This makes the application more reliable and more professional. This image represents the main flow of the CV chatbot application. The process starts when the user asks a natural language question about the CV. For example, does Jordi have experience with DDD? The question is sent to the .NET Web API. The API does not answer directly. Instead, it starts a controlled backend process. First, the application converts the user question into an embedding. An embedding is a numerical representation of the meaning of the question. Then, the application uses that embedding to search for the more relevant chunks of the CV stored in the PostgreSQL with pgvector. After that, the system builds a prompt. This prompt contains three important parts: the role of the system, the retrieved context from the CV, and the original user question. Finally, the prompt is sent to Ollama. Ollama generates the answer using only the provided context. The key idea is that the AI model is not working alone. The backend controls the process. It retrieves the question, retrieves the context, builds the prompt, calls the AI model, and returns the final answer. This is the main idea behind the RAG. First retrieve relevant information, then generate the answer. This diagram represents the architecture of the solution. The most important point is that external systems should be connected through the infrastructure layer. Ollama, PostgreSQL, pgvector, file storage, and PDF processing are technical details. They should not be directly referenced from the domain layer. The application layer defines interfaces and use cases. The infrastructure layer implements those interfaces using real technologies. This means that in the future, we could replace Ollama with another AI provider or PostgreSQL with another storage system without changing the core business logic. That is one of the main benefits of combining DDD and clean architecture. Let's summarize the most important ideas from this chapter. First, this is a realistic project. We are not building a simple CRUD application. We are building a web API with local AI storage integration. Second, the backend flow is clear. The users ask a question. The system retrieves relevant context, and the AI generates an answer. Third, the chapter gives us the foundation for the rest of the module. In the next chapters, we will explain Ollama, RAG, embeddings, and how to organize the solution using DDD and clean architecture. The goal is to understand both the AI part and the software architecture part. Thanks for watching. In this demo, we built a CV chatbot powered by Generative AI using ASP.NET Core Web API, Ollama, RAG, PostgreSQL with pgvector and clean architecture. See you devs, have a nice day.